the underlying asset and borrowing or lending cash, right? So combining either a long position or a short position in an underlying asset. And naturally, if it's going to be a long position, which means you're buying the asset, then you will have to borrow money to buy the asset. And if you're short selling the asset, then you're going to get cash and you're going to lend that cash. So if you will do that, you're going to replicate the exact cash flow stream which you will otherwise get from a derivative. And naturally, because we're talking about all of this in derivative pricing context, this means that the pricing of the derivative should be such that even if you replicate the same thing, the payoff should not be different. So an investor should be able to make the same amount of money by buying that derivative as compared to an investor which is buying the, let's say, asset and borrowing the money for doing that, right? So to understand this in more detail, let's look at example 2 from the curriculum, which demonstrates how a forward commitment can be replicated by purchasing the asset at the spot rate in the spot market, and you are going to do this using money which is borrowed at the risk-free rate. So we're going to be looking at the same example, which is of gold, which we looked at in the previous video. The only difference is this time the spot price is a little bit bigger. So if you remember, last time the spot price was around 1170 and the future price was 1792. And what was happening was that even when we were buying at this spot price and loading it up with the time value of money with the interest, we were still getting something which was less than the future price, and therefore there was some arbitrage possibility, right? But now this is not the spot price anymore, therefore this is not the future price anymore. The spot price that we have is 1783.28, and if you actually load this up with your interest cost, so you multiply the spot price with 1 plus the interest rate to the power t, what you will get is exactly 1792, which is equal to what the future price is, and therefore there is no arbitrage possibility here. The arbitrage opportunity is eliminated. Now what we are going to do over here is we're going to compare and contrast two possibilities. One is that whether we buy directly gold at this price in the future, or we buy gold now at this spot price using borrowed money, and then it's going to cost us the same thing by the time we reach the end of 3 months, right? So what we want to establish in this example is that the payoff should not be different whatever we do. So there are two options or opportunities with us. Number one, we get into the derivative agreement, which is to buy gold in 3 months time at this price. Now if by that time gold has gone up to 1900, that will mean 1900 minus 1792 will give us a profit, and because we are buying 100 ounces, so we're going to have a nice profit of $10,787. Or if by that time gold price has come down to 1700 per ounce, which means we're going to have a loss per ounce of approximately $92.13 loss, right? And that loss again will be amplified because it's 100 ounces, and we will have a loss of $9,213. Now these two things are important: the profit of 10,787 and the loss of 9,213. When the gold price is going to 1900, we're having a profit of 10,000, and when the gold price is going to 1700, we're having a loss of 9,000 if we are getting into the derivative long forward commitment. Now let's replicate this, and instead of getting into the derivative to borrow gold in the future, let's say we buy the gold now by borrowing the money. So we borrow the amount equal to the asset price right now, and we buy the asset price, and we take this cost. This, by the way, should be to the power of 0.25. And we take this cost and we load it up with the interest of 2% per annum, but because since it's annualized and it's 3 months, and 3 over 12 will be 0.25, so that comes to 179213. And if you see that the payoff is exactly the same, so if the gold price in dollars goes up to 1900, we still make the same profit. And if the gold price comes down to 1700, we still make the same loss. So the point that is being emphasized over here is that no matter whether you are buying the derivative contract or you're replicating the derivative contract by borrowing the money and buying the asset, the contract is priced, the derivative is priced such that there is no arbitrage opportunity, which means the future price is equal to the spot price multiplied by 1 plus r to the power t. So both choices will result in the same payoff, and we can say that the forward commitment can be replicated by purchasing the underlying asset in the spot market using borrowed funds. Let's look at an example. So here we are going to say that we're going to get an asset, we're going to buy an asset, and we are also going to sell the same asset in the future. And what are we buying? We're buying 100 ounces of gold, and the price is 1783, right? And we are selling it at the same time in the future for 1792. So what you're doing right now, you're paying 1783.28, and you're going to sell this in the future, and you're locking that transaction from now at 1792.13. So it looks like a very good business transaction that you have done, that you bought here, and immediately in parallel you have sold in the future, but the contract is happening right now, so you've locked your sale at a decent profit. Now this decent profit, how much is it? So when you will actually calculate how much this profit is, you will come to realize that this profit is equal to the risk-free rate. So you have basically just earned the risk-free rate. And why that is because you have not really taken any risk, right? Because I mean, you're buying the asset right now and you're selling the asset in the future right now because you're having that contract right now. So since you're not taking any risk, the only return you deserve to earn is the risk-free rate. Now let me show you the answer as well. So here you can see that we bought this asset 100 ounces at 1783. So the 2 zeros you see extra is because it's 100 ounces. So it cost us $178,328, and then obviously we're selling it in the future at 179,213, and there is a profit. But this profit, if you see, is going to equal to the risk-free rate, which is 2%. So we have earned the risk-free rate, and this is all we're going to earn because we have not taken any risk. So this is okay. As long as you're not earning more than the risk-free rate, that means there is no arbitrage opportunity here in replication. So this is replication with respect to derivative pricing. So this example demonstrates how Procam can earn and hedge its long gold cash position with a short derivative by selling it in the future and earn the risk-free rate as long as no arbitrage condition holds. This is the no arbitrage condition, that the spot price multiplied by the 1 plus risk-free rate to the power t is equal to the future price. Note that if they are borrowing at the risk-free rate and purchasing the asset today, it will earn 0, because naturally the rate that they will earn, they have to pay in interest to the bank that they have borrowed the funds from.